Good day, beloved interns, ladies and gentlemen. It's a wonderful Saturday afternoon here in Lagos, Nigeria. For me, I'm doing this call. It will interest us to know that over here in Lagos, we're experiencing rather cloudy weather with a bit of rain. And with this presentation at this time and weather, I can confidently say that we are up for an outstanding afternoon. I therefore welcome you all to this premiere presentation of the May 2021 cohort of the Hamoye Summer Internship. My name is Orika Precious, and I'm a data scientist at Hamoye AI Labs. Before moving, I would like to call on Tusha, who is the first person to join us in this presentation webinar. Tusha, can you hear me?
Hello, am I audible?
Yeah, you are. So, how's it like over there? How's the weather like over there? And where are you calling from?
Sorry.
I said, how's the weather over there? And where are you joining this call from?
Mm, I think
Okay,
I'm a voice lag or something. I can't hear you properly.
okay. I meant, where are you joining this call from? Where are you joining the call from?
Oh, I'm from India.
Okay, so how's the weather over there? Is it raining or is it sunny or cloudy?
It's pretty hard over here, yeah.
Okay, that's nice to know. So, what are your expectations for today's presentation? What are you expecting? Do you have any
Uh,
expectations for today?
yeah, I mean, along with our teams, we have prepared well for these presentations, and I'd like to learn a lot more from others as well.
Okay, that's great. That's great. So not to waste our time, I'd like to say at the start of the internship, we had people sign up for the data analysis, data science, and machine learning full stack, right? So even though everyone was working on different projects and learning from different prospects, the vision has been one and the same, which is building the future of work. So our data science interns, they started off on an amazing note, breaking down some machine learning algorithms, problem-solving paradigms in the period. And voila, we'll see some of what they've learned and what is to come in the premiere presentation right away. So before we go straight on, I'd like to welcome our judges. We have with us Zaliat Mohammed. You could just show the video of yourself right now. Um, Zaliat Mohammed, she's a graduate of computer science and advocates for the African women in tech. She's a data science and coding mentor to hundreds of people, and she's also a lead data scientist at the Hamoye AI Labs. Zaliat has spoken in different conferences and workshops on the different subjects of data science and machine learning. We also have with us the privilege to host amongst us Sophia Jack. Sophia is a project assistant, a cloud engineer, computer and data engineer, and also a data scientist at the Hamoye AI Labs. She holds a master's degree in project management from the University of Manchester. And I would like to let you on a secret. She's a multiple recipient of Most Outstanding Intern Award at the Hamoye Data Science Internship of 2020. Then we have the third judge with us, who is Gurav Jain. He's an astute computer data scientist and also a computer scientist. He's led different teams to great project success, including projects on subjects such as climate change, green energy, heart failure, survivals, and so much projects. Gurav is a student at the UCIST there in India, where he's pursuing his BTech. So even though I know we are all itching to hear and see our interns present in their projects, so just before we move on, here are some few housekeeping rules. The first is each group, you're expected to make your presentation in not more than 10 minutes. And at the end of every group presentation, the judges reserve the right to ask any questions at all. The judges will give their recommendations at the end of all presentations. Then if you have questions or need to make comments, please use the chat box and it will be attended to promptly. Then if you must speak, feel free to raise your hand and you'll be unmuted. Then to the presenters, please ensure you display your name so that we can easily identify and grant you the sharing permission. So, and now for the presentation, allow me to welcome to the first group Tushar, who is also the first person online, and Blessing Adibola for the presentation. So, Tushar, are you ready?
Yeah, thank you, everyone.
Okay.
So, hello everyone, I am Tushar, and along with my group today, I'd like to present to you our very first project, which was data analysis on electric vehicles. So, as you all know, vehicles have become an important part in our lives, and they almost everywhere we go, we see vehicles like as in cars or motorcycles, etc. And what we all know is they consume a form of gasoline or fossil fuels to power themselves. And I think it's safe to assume that we are all familiar with what gasoline and diesel power cars are. So, but what we do know is the age of fossil fuel powered cars is likely coming to an end. And here's why. Unfortunately, the fossil fuel powered cars are contributing substantially to the overall global climate crisis.
Tushar, I think
Okay,
you need
yeah.
us, yeah, you need to show us your slides so we can see what you're presenting.
No, I'm trying to present an overview of first, then we'll start with the slides.
Okay, all right, no problem.
Yeah, so where was I? Okay. Yeah, substantial. I was talking how the industry of fossil fuels is coming to an end, right? So yeah, the transportation industry in general is contributing around 16% to the total of the world's greenhouse gases, which is quite a lot. And even though these numbers on these charts are high, we're going to need transportation in the coming future as well. So what might be the possible solution in order to reduce these greenhouse gases, the amount of greenhouse gases these cars are producing? One of the innovative solutions might be to switch to electric cars. And what me and my team have done is we extracted a data set from Kaggle on the electric vehicles. And what we did was the analysis over the data set. And yeah, okay. So at first, I'd like to give you an overview of about the things of an electric car. So an electric car is the one that is propelled by one or more electric motor using energy stored in rechargeable batteries. Compared to internal combustion engine vehicles, electric cars are quieter, have no exhaust emission, and lower emissions overall. So these are the advantages of electric cars over the diesel cars. Okay, so there are different types of electric cars. An electric car using solar panels as a power source is a solar car. And electric cars powered by gasoline generator is a form of hybrid car, which means it takes both the things like electric and gasoline. Thus, an electric car that derives its power from an onboard battery pack is a form of battery electric vehicle, BEV, which often the term electric car is used to refer to battery electric vehicles, but may also refer to plug-in hybrid electric vehicles. Now, what I'd like is to ask Blessing to share what our findings were. So, what do you, Blessing?
Hello, everybody. My name is Blessing Adebola, and I'll be sharing some insights on our data. So we got our data from Cargo, and then I'll be sharing some insights on how we analyzed our data. So we used Jupyter Notebook, where we first imported NumPy, Panda, Matplotlib, and Seaborn. So we exported our data to Jupyter Notebook, and the first slide is showing the output of what our data looks like. Then next, we checked our data for which of our columns. This is the list of our columns, the brand, model, the acceleration per second, top speed. So we checked which of our columns contained an empty cell. So this line of code is to show which of our columns contain an empty cell. So none of our columns have an empty cell. So we went further into our analysis where we checked the powertrain against models. So we checked the powertrain of we have over 100 model of cars from different brands. So some brands have multiple models of cars. So we checked the powertrain against models. So we have AWD powertrain, we have the FWD powertrain, and then we have the RWD powertrain. So 41 models have AWD, then 36 models have FWD, and then 25 models have RWD. So beside a line of code and output is a graph showing the model, the powertrain against model. Okay, so next we run an analysis on body style. So this body style is the style of the cars, the style of the car models. So we check how many cars have SUV as body style. We have SUV, hatchback, sedan, liftback, cabrio, SPV, and so on. So we check how many cars have these models. So we ran an analysis against both. Then next, we also did an analysis on the model of the car against the seats. So some cars have 7 seats, some cars have 6 seats, some cars have... Hello, everyone. Okay. Can everybody hear me?
Yeah, go on, we can.
Okay, so we ran an analysis on how many models have this number of car seats. So this is a graph showing the model of cars that have the highest number of car seats is five number seats. Then we ran an analysis on the rapid charge against the price of the electric cars. So the prices of the electric cars goes as far as is in euros. The price of the electric cars are in euros. So we ran because most electric cars are all in a bid to check which car can go on a higher range and which car has rapid charge. So the electric cars are trying to improve on this attribute. So we ran an analysis on rapid charge against euros to check which cars with a yes rapid charge, that's cars that charge rapidly, if they have more prices, if they have higher prices than cars that do not charge rapidly. So this graph shows that cars that have a rapid charge of yes have higher prices than cars that do not have rapid charge. Then next we ran body style against powertrain. So body style against the powertrain, which style of cars, what is the what powertrain did they use? So this table shows the analysis also. And next we ran battery pack against range. So the battery pack is the battery pack of the car against how far the car can go, the range. So we ran battery pack on the x-axis and range on the y-axis. So cars with battery pack above 200 go a further range than cars with battery pack of 16. We also ran an analysis on efficiency against brand. So how efficient is the car and what brand of car? So here we, for this line of code, we combined the full name of the car against and the brand to get the brand names. So because multiple cars have different brands, different models rather. Multiple brands of cars have different models. So we joined both together and then ran the analysis on it. We also ran an analysis on accelerator against brand. So acceleration per second for each brand of car. So which car accelerates faster. So here we have the Renault Kangoo Maxi has the highest acceleration per second. So it currently has the highest acceleration per second of all the cars. And then we also ran an analysis on top speed against brand. So which car has the highest top speed? And here we have the Tesla Roadster. Tesla Roadster currently has the highest top speed. We then ran an analysis on price of cars against the brand. So the Tesla Roadster also is the most expensive. According to our data, Tesla Roadster is the most expensive brand of car. It also has the highest top speed. So that's all the analysis we ran on our data set. In conclusion, since the first electric vehicle prototype was built, the central challenges most electric cars have is to build lightweight and durable battery that also have adequate range. So electric cars nowadays are trying to increase the range that their models have. So and also we noticed that the cars with better range also have the highest prices. Thank you very much. That's the end of our analysis.
Wow, that was awesome. Very interesting. I know we are all excited to hear what our judges have to say. Okay, I'll call on Zalihat to start with. So Zalia, what do you think?
Can you guys hear me? Good afternoon, everyone.
Yeah, we can.
Can you hear me? Okay. So I have just few things to point out. So I think my first question goes to the first presenter. So why did you decide not to share your screen while you were introducing the topic?
Could you repeat the question, please?
Yeah, before when you started the presentation, right? You didn't share your screen. Then you said something about. Okay.
I was trying to put up an overview of what our slides are gonna be.
Okay, so one of the reasons why it's better to share a screen at first is because right now I don't know what you guys are doing. I don't know what the topic's about. Because if you had shared your screen, even if I can't hear you, I would have seen the topic. So can you share your screen again? So another thing is, while you're presenting, you have to keep sharing your screen, even when you're done. So in case we have questions, maybe you have to go back to maybe a previous slide or something, then we can ask from there. So can you share your screen again so I can see the topic? The first slide, yeah. Okay, so can you just briefly explain what you were trying to achieve with this project, like from the business perspective?
I think what we're trying to achieve is how the ways in which we can improve the quality of our electric cars.
Okay.
As they're going to be the new future.
Okay, sorry, I didn't really get that. So you said something about electric cars. What?
Yeah, I did. What I was trying to say was the cars we are using currently have been producing a lot of greenhouse gases. So what we can do is switch to an alternative, which is electric cars, which could be the future of this generation.
Okay, so does that mean that electric cars are more probably they are less costly? Because I saw something about, I think in one of the slides, that one car was like the most expensive but the fastest. So is it that they are more expensive? And so like I didn't really get that.
Yes, they are expensive for sure, but I think in the coming future we might be able to find ways in order to make it affordable.
Okay, so what's the problem you're solving now with this? And that's what I'm trying to get. Like, why should I abandon my manual car that is cheap for the electric car?
Well, first of all, it's producing a lot of greenhouse gases, and which is not good for our environment for sure.
Okay.
And even with the increase in price, they give quite a lot of features as well, the electric cars, as they are noise friendly and they have they are better.
Okay, so another thing, yeah. So why didn't you like use more interactive chats? Because I think I was seeing quotes and charts in the same. So yeah, even this introduction, like if there were points, it would have been easier for me to just get what you are trying to say, and I wouldn't have to ask you to go through the whole thing again. So why didn't you use like more interactive? I don't know. I wasn't really impressed by what you have here.
I'm sorry for that. I think we'll take this into the next consideration of our second project, and we'll definitely try to improve in that.
Okay, so can you go through the chart? Sorry, I think the first analysis that you have. Okay, so this one is no, the first one. No, that's the second one. Yeah, car, electric cars, powertrain. Okay, so this is comparing what and what again? Can you hear me?
Yes.
Yeah, Blessing, you can. Yeah.
Okay, so this
I
is
think it was
the powertrain against the car models.
okay. So what's the powertrain?
Okay, so the powertrain of the car is how fast the car can go from.
Oh, okay.
It can accelerate from the front rear tire to the back rear tire.
Oh, okay. So the second one, that's the next.
So the next is body style against model.
Oh, okay.
Body
So
styles
yeah, I think it's fine. But for presentation's sake, if I wasn't a data scientist, I'm not really interested in the code. So you can remove the code and just show us the chat. Thank you.
Thank you very
Yeah,
much.
I'll hand over to Gaurav.
First of all,
Yeah, Gaurav.
yeah, thanks, Zalia. So there were few advices which Zalia gave, and like, and in the same continuation, I would like to say that I see this project as a kind of data analysis project rather than data science project, because you are like analyzing the data and extracting out features from those. Yeah. So in this, can you like, as you told, your problem statement deals with emphasizing electric cars rather than manual cars, but all your analysis is around the comparison between different electric cars. So I think there is some conflict in problem statement. Can you please justify whether it's comparison between electric car and manual car, or it's a comparison between models of electric car? Blessing to share.
Model analysis on comparison against different electric cars.
Different electric cars. So just assume like I am a car manufacturer, like a multinational company owner, and I want to extract some things out of it. So can you just point me two observation which you think like useful to me out of this analysis?
Okay, if you're going to check for which brand of electric car you'd want to purchase, then you would go for electric cars that have higher efficiency, range, that has a balance between efficiency, range, and then the acceleration per second, because you want a car that can go fast, that has a good efficiency and also has a good range. So currently, the car with the best range now is the Tesla.
Okay.
So the Tesla Roadster has the highest range currently.
So that's for a customer perspective. I'm asking, I'm a car manufacturer, so I manufacture a car. So in that
I'm sorry,
context,
I don't understand. Sorry,
yeah,
I don't understand.
okay. So I am a car manufacturer. I manufacture a car. So let's say I work in Tesla as a data scientist, and I have to give insights from this analysis. What would be those?
Okay, so since you work for Tesla, that means you want to check how well your brand of cars functions against other brand of cars. So
Right.
you have to check what is brand selling points. So how what do your car have against other cars for customers to purchase your car? So you want to work on the top speed of the car, the range, the acceleration. So you want to compare your brand of cars against other brands for efficiency, top speed, and then range and battery pack also.
Okay. 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 That's nice. And as a continuation, so would you like to, as you've made this project, were there any, what do you say, limitations or any breakers you faced in this project?
Yeah, because yes, there was a certain limitation on getting the brand years.
Okay.
Yes, our data set not contain the brand years, which will have actually aided our data sets more for the analysis.
Okay. Okay, that's fine. So just can you go to the last conclusion slide? Okay. Okay, that's fine. I think like you can extend this project to some good level. You can include some more interactive visualization as already been said. So you can like use other graphs as well. Also, yeah, just one last thing. In the slide 18, you have plotted the graph on the downside of the axis. Is there any particular reason for that? On the slide 18.
Yes. I'm sorry, you mean my graph is upside down? It's
Yeah, right.
for better visualization, actually, and better understanding. So when you look at it, you could better understand where the x-axis and the y-axis is located.
Tushar, can you please go to slide number 18?
8.
18, 1, 8, 18.
Okay.
Yeah, this one.
Yes.
So basically, generally negative y-axis is like it's considered to be negative values. So like you generally tend to keep the graph in first quadrant only if it's depicting positive values. So you can work on that as well.
Okay.
Also, yeah, that's fine. Overall, it's fine. You can just make each analysis as more conclusive. So you can have conclusion from each analysis and try to focus more on what exactly the problem statement is. Because I think there was some confusion from what you spoke and what was there in the project. That's
Okay.
from my side. Yeah, I will hand over to Sophia. Yeah, thank you.
Work on these corrections. Thank you.
All right. Hi, Blessing Atusha. Nice presentation. Nice visualization. Your data visualization is quite clear in some places and it's okay generally. So like my colleagues asked, what problem are you trying to solve? Like Zali have said, you should take note of that. What is your business problem? That should be your selling point for your customers because you're being prepared for the field of data science. You're being prepared to work as a professional. So to take notes, first of all, you're trying to solve a problem. What problem are you trying to solve? What are your assumptions? What is your hypothesis? I mean, you're dealing with electric cars here. You ask questions like, is there a relationship between the price of cars and efficiency? Or is there a relationship between the car prices and the brands? Does the brand or the manufacturer determine how costly the car is? I mean, those are the kind of questions you should be asking. And also your data sets, you should have your independent variables and your dependent variables. I can't see any of those. Are you trying to predict the price of cars? What exactly are you trying to do? You need to understand that. Then take me to where you have AWD, FWD, and RWD. Can you hear me?
Sorry, I didn't get out. What did you say?
Let's get to the slide where you have AWD, FWD, and RWD.
Okay.
I just want to point out something to you there,
All right.
which is necessary for your presentation. I think slide 4 also. Okay, yeah. When you have something like this, it's good you explain the acronym. Let it be clear. in your presentation, in case you have people that are listening that are not really conversant with cars, AWD, all-wheel drive, four-wheel drive, rear-wheel drive. So the question here now is, okay, um, or what is the essence of this particular data visualization? Is it saying AWD is the most preferred by customers?
You're saying which model, how many model of cars use the AWD powertrain, and shows that the AWD is the preferred powertrain since most models use it.
So what's the essence of that? Fine, most models come with AWD. I mean, these are different features that the cars come with. What is the advantage? Do you understand me?
Yes.
What moves in the market? What are customers going for? That should be at the back of your mind. As a salesperson, let's say you're working for a company that manufactures electric vehicles. Your customers should be at the forefront of your mind. Do you understand? What are customers going for? Are they going for the brand? Are they going for car efficiency? Are they going for powertrain? I mean, those are the questions that you should be answering. Do you understand my point?
Yes, I understand.
Yes. And then also, I didn't see any modeling. You didn't do any model training or validation. Why is that? I suppose you've learned about model training and validation.
Yes.
Okay. And you didn't do any of that. Please take notes. You're going to be doing an open source project, which is going to be a major milestone for you. So take note of that, please. Ensure that you do your model training and evaluation, because that's going to help you as a data scientist. And then finally, what solution are you preferring? So the solution you're preferring should be dependent on your business case, the questions that you have asked yourself. So I think that's all on my end. So take note of this point, please. So overall, nice presentation.
Thank you.
So Blessing, I think we've gotten some tips from our judges, and I must say it was a very, very nice presentation. I think I understood some comparisons with the top speed, branding, and power efficiency, and how it contributes to purchase for these brands of cars. So before the recommendation, I would like to call on our second presenters, which is Coach Jane and Anuj Tawa. So if you're available, you could share your screen shortly. Coach Jane. Okay, all right.
Is my screen visible?
Yeah, it is. All right.
So today I am going to present the project on behalf of our group. The group's name is IMT02. These are some of our members who worked on this presentation. Now in this model, we created an algorithm which predicts the best suited movie for the user according to their favorite movie. Now you may ask, what is the necessity for such a model? So during the pandemic which we are facing currently, the online content industry has boomed a lot, with people having more time to spare than they can imagine. Also, it is predicted that this industry is likely to surpass the $200 billion mark by the next year. In this infinite pool of content, it is very difficult for a person to actually find out something that they might like. So the need of the hour is a software which can analyze a user's behavior and recommend them content that they might like.
Even the big tech giants like Amazon and Netflix are obsessed with capturing this market. And the key to this market is perfect content recommendation system. So our data consists of two files. One is a file that contains list of movies along with their genres, and other is the ratings file which consists a list of movies along with their ratings. During the analysis we conducted, we made a density plot of the ratings, which is I'm showing on the screen right now. Also, the movies were split according to the genres so that we could understand how the movies are distributed across different genres. Looking at this plot, you can clearly see that most of the user ratings range between 3 to 4. Now, I come to the approach we used. Firstly, we created a recommendation system based on the user ratings by trying a statistical model. In this model, the user was asked for a movie that they liked, and based on the other ratings for that movie, we recommended a movie which had similar ratings. But this approach was not great because the ratings of a movie are not a good feature. Then we moved on to the different approach, which was a clustering approach, where we used k-means clustering algorithm. In this model, we let the user choose a movie and recommended them different movies based on the cluster they were present in. Let us have a look at the working model. I request my friend Anuj to post a link in the chat box for our viewers. I'll myself also move on to the deployment. Is my screen still visible?
Yes, it is. It's still visible.
This is the deployed version of our model. So as you can see from this drop down, the user can select any movie that they prefer, and then the model will start processing the movie and recommend a few movies which it finds similar to the given movie. Like here for the selected movie, The American President, the top matches are Burnt by the Sun, Shallow Grave, Frenchie's Particle, etc. Coming back to the slide, we have reached the conclusion. So according by working on this project, we reached the conclusion that the large pool of content being thrown upon the people who are looking for entertainment, they find it very difficult to work their way through the content that actually suits them. So applying machine learning, we built an artificial filter that would help people bear with the process of going through such trouble. Some of the challenges we faced were lack of features that adversely affected the performance of our model, the inability of user to provide us feedback with the movie that they were recommended. Also, a major problem that every recommendation system faces is that they are biased towards the old movies and have a difficult time recommending a new movie because they have higher amount of ratings and reviews. Also, some of the ways we could have improved our model by is we could have built a different model which had better features. We could have gathered users input into our model so that we could better our way to recommend. So we could have also taken users input and upgraded our model. Thank you for being a great audience. Now let's move on to the questions.
Wow, that was really great. Okay, so let's move on to Zaliat now for your questions.
Wow, I'm really impressed. This is a very, I think this is one of the best presentation I've seen in a while. Yeah. So I love this topic. I love the presentation, and I love the fact that you even have time to deploy this. At Hamoye Air Labs, we've worked on. It's not okay. It's not about movies. It was like a recommender in general, not a particular condition. I'm not really a fan of movies, but I like the fact that you can take this project from just movie recommendation to other projects, because you know, recommendation is like one of the best things that machine learning offer, because you can have recommendation in clothing, in fashion, you can use it in movies, in music, even in recommending books. So this is actually a very great project. So I just have a few questions. So what algorithm did you use for this? Because in recommendation systems, I know we have collaborative filtering, we have hybrid, and we have content filtering. So which of the methods did you use among the three? Can you guys hear me? Hello.
Yes, we can hear you. So, Kush Jane, I think she asked the question. Either you
So
or
I'm asking,
Anuj.
which of
I
the
think Coach is having a
method
microphone
did you
issue.
use?
Actually, we
Can you
use the
hear me?
k-means clustering algorithm.
So I didn't get what you said.
Sorry?
Hello? I didn't hear what you said. You said you used what?
Ma'am, I was saying that we use the k-means clustering algorithm.
No. What I'm saying is we have different approaches, right? There's the content filtering, right? Where you have contents maybe for A, and then we have contents for person B. Then if a person A likes maybe movie one, and person B likes movie one, and then maybe the person A now likes movie two. You now recommend movie two to the other person, because probably from the data you've seen that they have like similar preferences. Do you get? So that's for content. Then we have collaborative, where you have, I think, you use their own. So I think there are about three. There's content filtering, there's collaborative filtering, and then there's the hybrid, that's using both of them. So I'm asking which of them you use. But the algorithm is KNN, yeah? You said you use KNN, right? We can't hear.
Ma'am, actually, our approach was a little different from this. We filtered out, we are recommending movies based on the genres.
Okay, so you can check out what I just talked about. There are like the three different ways, and then you can check out TensorFlow recommenders. I think TensorFlow released it around September. So it's a library where you can easily create recommendation. What do you call it? Recommender systems, and you can easily deploy it using maybe TF7. So maybe you should check that out. So yeah, the presentation was nice. Overall, I'll give it a 10. It's a nice one. I'll hand over the control to Brad.
Thank you for the suggestion, ma'am. We sure will look into the other algorithms as well. And that sure is an improvement to our project.
So,
Great.
All right. Thank
great
you.
presentation, first of all. So, just a few things like I want to ask about the analysis. Can you go to the analysis slide where you specified the three types of graph you will be making? Just one before this. Yeah. So you mentioned like density plot correlation and genre-based distraction. So, like, have you done some visualization in all the three categories, or only density plot was made? Hello, I'm audible.
We were a little inclined towards the density plot.
Okay. So, and what are the outcomes of the density plot? Is like any particular thing which you got to know?
From our first approach, we tried using movie ratings, and for that approach only, we used the density plot. With the help of density plot, we came to know that most of the user ratings range in between 3 to 4.
Okay.
Otherwise, it was a regular graph, regularly distributed graph.
Okay. So, what like you can say, it's sort of a bell curve. If we just take an overview, is that what you mean?
Yes.
Okay. Okay, yeah. So, like, you can just a suggestion. You can work more on some analysis, because there are in the recommender system specifically when you are dealing with the movies data set, there are various things which you can extract and which can help you in choosing the best model. So, as you said, like you will be improving on the model, so it's a good point to work on the data set you have. Okay. Yeah. And apart from this, like you used k-means clustering, right? Or you used KNN? What did you use? Is it KNN or K-means clustering?
We use the k-means clustering algorithm.
Okay, so it's an unsupervised algorithm. So basically, what parameter did you use to cluster the movies? Is it like the rating, or is the genre, or like an overall clustering?
Genre is to cluster the algorithm, make clusters.
Genres. Okay. Okay. So like you can include more parameters in this, because like not only genres always help you in the same. Okay, and can you please specify what is the source of the data set? Where did you fetch the data from?
Our data set
Which
is
one?
from Movie Lens.
Sorry, can you just repeat?
Our data set is from a website called Movie Lens. Has a, uh, it has a variety of different data sets and different sizes of data sets on that website related to movies and TV series.
Okay, so like I hope this is an original data set. It's not like artificially made.
No, this is an original data set.
Okay, and what error metric do you used in the machine learning algorithm? What did you count on for improving the model? I'm audible. Hello. So
Can you
I'm
please
asking,
repeat your question?
what error metric do you used in machine learning model to improve like a hyperparameter optimization and all that those things? What parameter did you use? Is it like accuracy, precision, like that? What did you use?
Clusters.
You have clusters, I know, but like to improve it, what was your approach to improve it?
While making this movie recommendation system, we faced one major issue or error, you can say, that in some movies, when the we tried different numbers of clusters, and in that we were getting different uh, all the clusters, there was a different number of movies. So there were some clusters in which there were only one or two movies. So due to that, we were not able to get recommendations for those particular movies. So we tried multiple values of clusters to find the perfect fit. So
Okay, yeah,
we
like
I
just
noted
a
that
suggestion
manually.
for like you can search more on it. So for clusters you have like various techniques like elbow curve and all those, but for this
Mhm.
context, like as Zaliat already said, there are techniques like collaborative filtering, content filtering, so you
Mhm.
can approach those as well. This was from my side. Overall, I like the presentation. I like the point that you deployed it using an open source project, and yeah, good work.
Thank you.
Over to you, Sophia. Thank you.
Right. Nice presentation. Well done for that. You stated your problem, the problem you're trying to solve. And that was made clear. Um, can you explain the statistical model we talked about? What exactly did you do?
Ma'am, I actually can't hear you.
Can you hear me?
Yes, it's better now. Better now.
Okay. You mentioned two approaches you use. Statistical model. What exactly did you do? What is the statistical model all about?
In the statistical model approach, ma'am, we actually we use the user ratings. So in that we in the
Are you
statistical
there?
model, we actually found the correlation between the ratings and between the ratings given by different users. So from the users data set and
Oh, okay.
to different movies, and according to what movie did the user the person who is trying to get a recommendation chose like
Okay, so
that
in
person.
essence, it's correlation, right? Is that what you mean?
Yes.
Okay, that means it's not actually an algorithm, it's correlation. You should have stated it clearly that you did correlation. Okay, that's fine. What features did you work with apart from
What
user
features?
ratings? Yes. How many features did you have? Or what are your
uh,
variables?
in
Is
the
it just
clustering
user
model
ratings?
we had in the clustering model we just had the genres as the feature, and in the other model
Okay,
we had ratings as the feature.
okay. All right, that's fine. What about the year of manufacture? Because I'm asking this question because I want to know if you did some like trend analysis, seasonality analysis, like which movies were trending at different years. Did you do anything like that? You should have done something like that so it can be more interactive. You can see and understand. And also, which genre is mostly preferred? Do you get my point? So those are some data visualizations that you could add to your presentation. Is very important when you're presenting to people. And also, it's good you deploy the model. Very nice. You could actually see the working of the model. It's very nice. I also want to recommend Kubeflow because you're going to learn Kubeflow in the course of the project or in the course of your internship. So it's good to try Kubeflow. It's also a good option for deploying machine learning models. Overall, nice presentation. Well done, guys. That's all from my end.
Yeah, well done. That was what Sophia, Jack, and the rest judges gave. So quickly, I don't know if you have questions for our judges. Um, Tusha and Blessing, I'm sure you have so many questions in mind to ask our judges. So we'll just give you guys like a minute or two to ask our judges some questions, probably to clear your doubts or probably on how to move forward or go forward with your project.
Actually, I do have one. So
Okay.
can I ask? Okay, so the thing is, our project, problem statement of our project basically mentioned to analyze different electric cars, and as Sophie ma'am said that we have to go for a model. So, what kind of model can we select to train in this kind of situation? What would be the optimal choice?
Okay, the model you're going to select will depend on your problem statement. What are you trying to solve? There are so many
The
models. Okay, you have
okay,
linear regression, you have classification. There are so many models, but it's going to be determined by your problem. That's why I asked you what problem you're trying to solve. Are you trying to make a prediction? Are you trying to establish a relationship between the price of the cars and the features or attributes of the cars? So that's what is going to determine your business case. So I can't say this particular model is suitable. Your business case will determine that.
All right. So
Okay,
I
well,
hope
thank
it's
you.
clear.
was that clear? Um,
Yes, it
Trisha?
was. Thank you very much.
Okay. And also to Kush Jane and Anuj Tawa, do you have any question for our judges? Probably on how to move forward with your project or something.
Thank you, sir. Actually, I had one question. So I wanted the judges' recommendations on how what other features can we include in this model. Like what other features should be considered for a recommendation system?
So I would like to answer that. For a movie recommendations is like when you consider a movie, there are various things you can consider. One
Mhm,
of course would be like the budget of the movie, the
mhm,
they say the actors involved in that movie, because some of movies you can also correlate, like there is particular preference to some actors or actress in that movie for
mhm,
some audience. And also like you can check whether that movie what revenue that movie had, so there's like hit
mhm,
movies or flop movies based on the revenue they generated. So these are kind of the feature you can have, like
mhm,
language of the movie, like because there are few people that say I'm more inclined towards English language, some would be more inclined toward, let's say,
mhm,
Tamil, Hindi. There are like so many Spanish, German, like that. So you can consider
mhm.
that those factors as well. But like in all, I would say first of all you have to do some analysis. Are those features actually useful? Because like it depends upon the data set you have. So you can consider these.
Thank you, sir. That
Great.
was a great insight.
Yeah, that was great as well. I think I learned so much from the recommendations from our judges. Without wasting time, um, actually, I was very impressed personally. I think from the what's it called, the automobile, the cars, speed and acceleration, and the brand of cars, and how it impacts users to purchase these vehicles from the comparisons made, and also the recommender systems used in movies. So it was also interesting. So I'm really, really amazed. I think I'm I think I'm very excited the level of progress we all have made using data-driven techniques to profile solutions that are really important in our society today. I must really commend the presenters for this wonderful presentation. And also, I won't fail to commend our wonderful judges for your wonderful pointers and recommendations. Thank you to the Hamoye Labs teams and everyone watching. Just a gentle reminder, please you also enroll in the study groups for your courses. This is one of the many criteria for you to be certified at the end of the internship. So we ensure or we plead for um, projects to be completed. Share your learning experience on the social media space. You could just tag us hashtag on Twitter, Instagram, on LinkedIn, Facebook. We can help you post. Just take advantage of the career coaching opportunities every month. The next of which is on Saturday, 10th of July 2021. And also, we will turn our attention to the capstone project and the grand finale presentation that was scheduled to hold on the 17th of July 2021. More details will be communicated as soon. It's important that we take active parts in the capstone project. I'm emphasizing this so that you can be certified. So we wish you all the best, and we hope you learned one or two things from the presentations, and I wish you all a great weekend. So thank you everybody for today's presentation. Thank you all, Auditon. So bye everybody.